Welcome to Densify Talks. Thank you so much for joining us. We really appreciate it. My name is Brian. I'm the producer of the show. Today, we've got some excitement for you. We're going to be talking with Josh Hilliker, Principal Engineer and Senior Director, Cloud Solutions Architect at Intel. Today, Andrew and Josh will discuss automated instance selection and the importance of letting machines make the resource decisions as cloud environments scale. Speaking from the perspective of a hardware manufacturer, Josh offers unique insight into some of the criteria that affect the performance and cost of hosting apps in the cloud, how to leverage optimization as code to automate the optimization process. He also provides insight into the latest Intel hardware accelerators and the cloud instances that they are available on. So let's get into this one and walk away with some excellent information. Here is your host, CTO and co-founder of Densify, Andrew Hilliker.
Thanks, Brian, and thanks everyone for joining us. I'm Andrew Hilliker. I'm the CTO and co-founder of Densify. And today we're joined by Josh Hilliker, and I'll let Josh introduce himself, and I'm quite excited about this discussion today.
Awesome. Thank you, Andrew. Thanks all for listening in as we talk through this topic today. So my name is Josh Hilliker. I have been at Intel for 28 years. I'm a principal engineer. My background is in infrastructure modernization and telemetry. Pretty much over the last 20 years at Intel, I've gone from an IT guy to manufacturing, to sales and marketing, to product with client, to data center, to doing training curriculum, to healthcare. And really just got a broad range of kind of what's happening in the compute arena the last almost 30 years. And the last 7 years has been really this double click into cloud and really double click into infrastructure when we come to the cloud. So as Andrew and I have been conversing over the last, can't even say how long it's been. This conversation for today was just very timely and something I hope all you guys are excited to listen in on.
One of the reasons I'm excited is, of course, because of your breadth of knowledge in this area, and we'll dig deep into that. But before we get there, you're also just a fun guy. And I think we were last together in Orlando at Intel Vision, and you invited me to join you in one of your sessions. Thank you for that. Get to know Josh. This is funny. We were prepping for the session, and you were talking about coming into the session, the real session, in an alligator costume. And I thought you were just joking, but it turns out you were kind of only half joking. You've actually done that kind of thing before.
Yes, indeed. Yes, I was close. Almost had to pull the trigger and do that. In the past, we have a cloud summit where we bring in customers and talk about technology. And we had it in Arizona a while back. I came in as a cactus. Basically MC the event in a cactus outfit. It didn't last that long because that Arizona heat is hot and that suit was hot, but boy, would that have been a shocker? That would have been a shocker to come up in an alligator suit. I think you would have lost it.
It would have been entertaining. So, and the cactus costume, I hope you didn't poke people with I hope there weren't actual real thorns on that thing. But that's Josh. That's so everybody knows. If you get a chance to see him live, he's obviously very entertaining. So that's the other half of why I'm so excited. So today what we're going to talk about is automated instance selection. I think it's a topic that's near and dear to both of our hearts. And I think just to give a bit of perspective, in previous podcasts, we've talked to some of our customers, I think some of our joint customers actually, around optimizing cloud and the techniques and issues around getting people to take action. This is kind of cool because we're going to turn almost in the opposite direction right now and talk about it from the supply side. So Intel being obviously a supplier of hardware into the cloud provider. So a very different perspective. And we talked a lot about cost. I think today we'll talk a little about cost and performance, a bit of everything. So I'm kind of excited to get into this because it's a different perspective than the discussions we've been having previously. So with that, Josh, I think it's worthwhile to start off just by saying we talked about like cloud optimization, workload optimization. What does that even mean? Let's just back to basics. Everybody uses those phrases, but what do we mean by that?
It's a great question. And I am equally, as you said, passionate about automated instance selection. So I'm so happy that we were talking about it. So workload optimization at the fundamental level, a workload, associate that with something like Nginx. It's a web-based, right? Or MySQL. It's a database. Those are the workloads. And you could say, well, what is that? Is it a t-shirt app? Is it a ordering site? Or is it a, key value pair store for registration info? All that feeds to me into like a database, or it feeds into a web Nginx. So it's taking that workload and optimization. Now, what's funny is I've been meeting with folks talking about optimization, last couple of years, optimization has like this breadth or range of what it means for folks. I met with this healthcare gentleman the other day, and he was talking about optimization for him make better patient care. I meet with folks on the FinOps side, and they're talking about cost optimization. I mean, with the developers and DevOps, they're talking about performance. So when we look at workload optimization, it is about taking a given workload and getting the right optimizations for it to run better, faster, and cheaper. So lower the cost, increase the performance, and make it really hum. So that to me is like bringing all the pieces together. Now, what's interesting is that we've been talking about workload optimization for, some time now from an Intel standpoint. I was watching the news recently, the tech news, and seeing that a lot of the other x86 providers are now starting to talk about workload optimization. And so to me, that is a sign of we got something good here. Our customers and partners are expecting it, and I'm just so thankful that we've been doing this for a long, long time, and we can lean in even more.
And I think it completely makes sense because you folks spend so much on R&D to host applications and to be able to help people optimize how the applications run on that infrastructure. It's a natural fit. So I think you guys have been ahead of the game. Performance and cost kind of go hand in hand. The analogy I give is that if I'm not using my laptop, if I have a giant laptop, but I'm not using it, I'm not going to get excited if you come by and say, I'm going to give you a laptop with half the CPUs. But if I give you one with half the CPUs, but they're faster CPUs, I'm listening. So even for a pure cost savings initiative, being able to milk the performance out of a platform at the same time is very important. And I think you guys are obviously well situated to do that with all of the things that you design. So, that's optimization. We talk about automated instance selection, and inevitably that leads to optimization as code. And maybe you can dig into that a bit because it's something we talk about quite a bit.
Yeah, absolutely. When we look at OAC or optimization code, we got to go back a little bit, and we go back to infrastructure as code. Infrastructure is that how are you modularizing? How are you putting that into machine language, right? And that's that first IAC journey. And still there's folks that are still on the journey of getting to infrastructure as code. The next step was policy as code, which is how am I doing governance? Up till recently, maybe prior to the last 2 years, there was a conversation more around like security and like how do I lock it down and how do I make sure it's not malicious activity and how do I guard the gate, guard the door, guard the tunnel, guard the container. Now that policy as code has really matured to this governance of how can I set policies and govern my infrastructure differently. As you move past that, it leads right into optimization as code. A couple of stats here that I think are intriguing. Two things. One is, and these are both from Gartner, one is that 70% of the provisioning will be done via machine-to-machine communication by 2025. That's a mind blower right there of like, whoa, wait, machine-to-machine is going to do the provisioning, not individuals, not DevOps, not operators. What? So that to me is like, wow, if you're not talking the right language and you are not already thinking about it, you got to think about it. The second item from Gartner is that through 2027, 85% of workload placement decisions will need to be continually optimized. Why? Because of changing product, availability, and cost requirements. We know there needs to be optimization. It needs to happen continuously. We know we got to start putting it into the right format for the engine to take it. And that's where optimization as code comes in. What if we can take all of the rich decades of optimization, software optimization work, put it into code, put it in the right format to enable that machine-to-machine communication, and kind of kickstart that continual optimization. And that's, to me, optimization as code, right? It's like, how do I get out of what we used to do is we'd provide a PDF and say, hey, here are all the parameters, the flags, the configurations. And now, no, I'm not going to do that. I mean, we still offer that, but here is now it in code as optimization as code. I'm going to continue on a little more, though, because you got to look at who are the players that are out there, right? Who is enabling this optimization as code? And the first natural player that pops up is the de facto standard for provisioning. So why provisioning? Provisioning is where, to me, the magic happens. It's where that instance gets established. It's where the selection happens. It's where the configuration starts. Who is the de facto standard in this space? HashiCorp, Terraform. Folks are on this call and have never heard of HashiCorp, I'd say lean in and check it out. If you're already an active user of Terraform, of course, there's different versions. There's Terraform Enterprise, Terraform Cloud, and OSS, but Terraform is it. So we look at what standard would we adopt to put OAC into. It's working with Hashi. And to me, that's been one of the great strategic collaborations we have in place actually right now is with Hashi on this very thing of putting the pieces together. Now, I don't want to spoil alert too far because I know we're going to talk about it in a moment of how the pieces all come together and why I'm so, I'd say, giddy about how Densify, Intel, and HashiCorp come together, but I'll save that. I know we're going to hit that here in a few moments.
I agree. There's a lot of exciting stuff happening, but just to unpack some of the things you said there, so there's really important points in there. Everything as code, like what we see is that humans can't do this in scale. Like once you get beyond a certain point, it almost parallels, like the VMware development over a decade that it really got big, where you can do a lot of bespoke stuff in the beginning, but at the end, somebody just needs to manage thousands of VMs automatically or through policy. And we're seeing the same thing in the cloud where you can't handcraft that many things. And containers, you really can't handcraft that many things. So, we firmly believe as well, the machine has to do it, make the decision based on all the policies. It's constantly changing. The cloud catalog updates all the time. We'll talk in a minute. Like you guys have some new stuff going into the wild. So you have to factor that in. And it's a full-time job just to keep factoring that in. So just to keep up with the supply side of the equation is a full-time job. You would never be able to manage thousands of things without things like Terraform and without doing optimization through Terraform. I totally agree with what you're saying there. So optimization as code, sitting on top of infrastructure as code. It's super exciting stuff. For a minute, let's talk about the different environments that are out there, because again, some companies have many different DevOps pipelines and stacks, and they have prod and dev. And so, that's a factor too. I think maybe give some thoughts on how you look at this holistically across an organization.
Yeah, absolutely. The landing zone matters. I was trained a couple of years ago when I had to let my pet go, aka my favorite server that I had branded, I had named, I had set all of the bash RC shorthands. I had made that the most optimal server that I had wrote code on. My team was like, hey, you got to let the pet go. We're into cattle land, right? And that goes back to that, how do you manage the fleet? You have to manage it as cattle, right? You have to manage it without that level of touch. Now, for the environment context, what's important is that how do you have to model between your different environments? So I like to talk about there's, pre-production, there's staging, and sometimes there's QA, then you go to production. And it's like, do all those environments need to match exactly? And in a lot of cases, no, not in the cloud. Now, in the data center side, when I was deploying applications, we try to, okay, how do we streamline? How do we compress? How do we do multiple VMs before we get to production so we could validate certain steps? Well, the same thing holds true in this space. It's like, do I need pre-production to look, or dev to look exactly like production? Or do I need to just do functional tests, functional checks? Can it validate that? Because sometimes you don't want to run a full load in dev, but you want to know is like, will the functionality work? So in the cloud, you can right size all that stuff, right? It's like, maybe you can go with a 2x large instead of a 24x large. Maybe you can go to a different N2 instance type because you want to just test functionality. Applying the same methodology needs to be thoughtful and mindful, as I'll say, on how do you approach it, what goes into which environment. Maybe just throwing a little bit about, kind of setting the rules. So I talked earlier about PACS, policy as code. It's like, how do you bring PACS into the mix of, okay, hey, look, this is how we're going to roll through our different environments to save cost. And, Andrew, you and I earlier were talking about the cost element of being able to take, if I'm able to streamline my pipeline, am I able to now apply some of that, more of those funds to my production instances, my production storage? Maybe I'll flip to a higher IO just to assist with the production demand and kind of reallocate those cost savings around.
Mm. It's almost a rob from the rich gives to the poor type of paradigm. And it's a great point because, well, backing up for a second, you talked about, does the non-prod environments have to be configured the same? And we've seen cases where the rule is, yes, they have to be configured exactly the same. In a container environment, that doesn't make it very useful for testing apps. If your test environment is the same as prod, but empty, then it's not a good test of whether your container is going to work, because of course it's going to work. It's going to be swimming in capacity. So there's no other workloads running alongside it. It's more important to model all the other workloads that are going to ruin your day than have the same size server, if that makes sense. So you have to challenge those policies and saying, does dev need to be the same as prod or, the test environments? It's going to cost a lot of money to make it identical and actually not be as valuable for testing things. So, that whole thing from dev to prod, we see a lot of cases where you can take the money you saved a ton in the non-prod environments. And like you said, we can still save money in prod, but maybe we can save a bit less and give you better service at the same time. which is a great segue, I think, to one of the things that I want to talk about, which is, let's get specific to Intel. This isn't an Intel infomercial. I'm not trying to sell Intel, but I've been working with you long enough to know that there's some pretty cool tech, like especially the accelerators in your chips. So, you guys spend a lot of time developing features that make certain apps run a lot faster. And most people are already even running on these chips, but not leveraging these features. So maybe you can talk a bit about accelerators, because it's one of the things I find the most interesting and probably the most practical for people to make sure they understand.
Yeah, absolutely. Accelerators are money. They're just money for workload specific, right? So like, for example, we look at things like QAT, Quick Assist technology, right? We've had it in multiple generations, but adding that into a work like Nginx, you start to see performance that is just fantastic, right? You see better, right? I'm going to see things at 3x better, right, than what you saw in the past. I definitely want to double click the accelerators, but I want to give one quick shout out to benchmarks, if I may. Benchmarks, another thing that I will say is are important. Knowing what the benchmarks are and real workload, real life, real workload examples, right? Like, that actually show you kind of certain, value, not just a single metric that's not aware of the workload. So in this space for our accelerators and for our products is we are absolutely doing deeper benchmarking. So in the database space, we go deep with things like HammerDB, and we're using that to do the testing to show, okay, how will it really perform with a real world workload? So these accelerators, we're using that same methodology of let's test it with a real benchmark that will show it. On the accelerator list, man, there is, Andrew, there is like an acronym soup of them that are out there today, as the best way I can say it. Of course, Quick Assist technology, yes, love it. Nginx, being able to add into the web space, right, of what it can do from a performance standpoint and better. AMX, advanced matrix extensions, you got data streaming accelerator. And how I'd look at this is, how do I become more efficient from a processing standpoint? What do I offload? How do I offload it? How do I make it so that it's going to perform better? I don't want to say use less, but use it more efficiently, right? So because density matters. In the data center, it was all about compute density. In the cloud, it's all about cloud density of how can I make this work better. Of course, we got AVX. It continues, AVX 512, so advanced vector extensions. That goes into the AI space, advanced matrix extension. I think I talked about already, AMX. Each one of these has either multiple use cases or certain type of like storage per se versus HPC or what have you. The key thing for Accelerator is, do you have it? Is it available? And how do I exercise it? What is the easy button to making it work? And that's where I really feel like we are really turning the corner on sharing that out from a recipe, from an adoption, from a use case. Okay, this is how you get to it. I know we'll talk in a moment about Sapphire Rapids, but the accelerators are absolutely big on Sapphire Rapids, and there's, excitement in the future, of course, with other things that are coming up. Know that they're there, know that they're available, and that as of right now that I'm seeing, the CSPs are doing a good job of giving that and making that available to you and making it available to our customers and partners that are leveraging those instances in the cloud.
The service providers, you can see when you go to the page for a certain type, it'll list the accelerators on the instance, but to your point, it's kind of like an acronym soup of different things. So I don't think everybody knows, what they mean. I'm fairly familiar because I've been working with you folks for quite a while now, partnering with Intel. And, we see a lot of software out there that will just run faster if you enable it. And one of my favorites is, you mentioned Quick Assist. And again, this is not an infomercial for Quick Assist. I like it because I believe, from my understanding, the enablement is pretty straightforward. For example, if you're running in a Kubernetes environment and containers are using SSL, all you need to do is put an updated OpenSSL library on the node and it will accelerate. So you don't need to change the workload. You just need to have the right drivers loaded. So you're not even really locked in. You're just leveraging that feature if the node's running on those chips. So I really love that one because the gain, like you mentioned, is so high for such little effort. If you can you have to start by being aware it's even there. So,
yeah. And
then it'll go faster. And then you mentioned density. Don't forget you're talking with Densify right now. This is, I can go on all day about density, but really that's where the efficiency comes from.
Yeah.
I think it's cool because I think, awareness of the accelerators is important. And then, like you said, you have things like the hub out there that start to detail exactly how to enable these things and what the impact's going to be. So it's pretty cool because, again, a lot of people might already even be running on Intel gear, but not be aware that they can flip the switch and have their Nginx or their WordPress or whatever go way faster. It's pretty cool stuff.
When I see stats like with QAT, 84% fewer cores to achieve same connections on Nginx with built-in QAT versus out-of-the-box software, that's where it's just like, okay, yep, I want to do that, right? I need to do that. Be aware, right? Be mindful on the configuration, be mindful on how you're applying it, and dig in. I'm realizing a lot of folks, when they make that cloud journey, they may say, hey, I got it out there, I'm good, but it's like, no. Still pay attention. Still click in a little bit more.
And even going back to a customer who's trying to save money, if you leverage these accelerators, you'll end up using less CPU. Like you said, you can actually, downsize things and save some money, but it's also just going to work much faster. When you process messages 3 times faster, even if your machine's not running at 100%, you just answer faster. The latency goes down for messages flying through. So again, I mentioned the laptop analogy, and I believe it, that you can kind of claw back some resources from end consumers, but still give them benefit at the same time. And that's kind of the win-win I think these things bring to the table.
That's why that I am so giddy about Densify. Right? I know you've heard me say that, right? I said in Orlando, and I've said almost every call we've been on, is I'm giddy because that cloud density matters, right? And right sizing, I'm saying it matters a lot, but all these topics to me I'm very passionate about. But it's like, right sizing your cloud infrastructure and being, kind of hyper aware and able to execute quickly on changes. It's why we're talking. It's like why Densify is so cool. It's like, I want to have that awareness. I want to, be able to make changes and understand how those connections can take place and prepare me for machine to machine.
So Densify, we talk about Densify, it is offered by Intel as Intel Cloud Optimizer. So that's the partnership we have, which is great. Part of the reason why Josh and I talk so much. So, but again, let's not make this into a commercial for Densify. Although that's fine if we do.
Sorry.
As long as you're doing it, not me. I'll talk up Intel, you talk up Densify, but we're both quite passionate about that because it's the future, it's where the industry's going. And to be able to come up with a very well-informed answer of what something should run on, like the instance selection itself, we both agree is key. And then being able to automate it through partners like, HashiCorp and Terraform, we're way ahead of the game on that front. So let's get specific for a second. We talked about accelerators. We talked about, some of the benefits. And then your latest in-market chip right now is Sapphire Rapids. And I'm not even sure if everybody's aware of that. Like I know it well because we work with you, but that's the latest gen. Is there any kind of insight? I know it has even faster quick assist. You want to give any insight into that?
Yeah. So we have R7 IZ is available in AWS. And what's funny is we have a job running that tells me where Sapphire Rapids at, which CSP, which AZ, and it's something I kind of drink my morning cup of hot water and I look at availability every morning. I don't know if that's a problem or not for me, but I look at it and say, okay, where are we at? Like, for example, so R7IZ is out there, and we got C3, GCPS3, C3 out there, and a number, it looks like over about 20 specific AZs. And so the capability of the accelerators is out there. It is ready to use. And I know there's more instances coming. I can't really talk about when, but there's more instances are hitting the market across the top CSPs. So that to me is exciting as those start to move into the different categories of instance types as well as proliferate across AZs. Now, one thing on the C3 front we're working on right now is that easy button. Is how do I get an easy button to show, like I'm using AMX matrix extension, and I want to be able to do that use case in an easy button. And we are actually developing a hashing module right now to do that very thing and be able to publish that to the world. Say, hey, here's an easy button for how you would make this work with a recipe, and that folks can just take up and either adopt or, take the code and put it into their code if they already have brownfield C3 operations already working. Super excited about when that comes out. Hopefully we'll see that out on our website and Hashi registry. And
of course, you say over your cup of hot water in the morning because you don't drink coffee because you're already wired enough, right? That's the reason. I'm sure that's the case.
Under advisement, I do not drink caffeine.
This podcast, if you and I both had caffeine before this podcast, it would be long over by now. So we're on the same page there. So one thing that blows my mind about things like C3s and the R7s that are coming out, a lot of times they're no more expensive than the previous gens, but people are just using really old stuff and really old. We've done analysis of this. I did a podcast recently on this. Part of it was on this where, you could be sitting on 7-8-year-old gear and you're kind of paying the same as you would for the brand new stuff. It's almost like if you're getting a taxi, of course, the taxi driver loves driving their car into the ground. It could be a 10-year-old car that's just, clapped out, but you could, for the same money, get in a brand new car. So, it's kind of like that in the cloud where staying current, there's a lot of advantages, the accelerators, being one of them, but you could just be on a lot newer gear. So sometimes if you don't let the machines make the decisions, nobody has time to go back and look at how they can bring all the old workloads forward onto new gear. If the machines are doing the decision making, that's automatic. It's just you're constantly modernizing and leveraging whatever the providers have. So I think the C3s, I believe, aren't really even more expensive than the previous gens. They're just a lot newer.
Yeah, you're hitting, Andrew. It's like, I'm surprised when I work, I get a architecture from a customer and they tell me, hey, here the instances run, and I do a quick scan and realize, hey, you could flip like 90% of these to a newer version and get less costs and like 2x your performance. Mm-hmm. And they look at me like kind of like, what? And I'm like, yeah. At first I was surprised, and now I'm not surprised anymore because it's almost like a daily event. Mm-hmm. And it's like, boy, when we can shift the machine to machine, think of all that automatic cost savings you're going to get.
Yep.
Right.
Yep.
Think about that, the potential, because you're right. People do set and forget, right? Architecture sent. I already know it works. I'm going to leave it alone. You're like, but you can't do that. No, That is the old taxi, right? Like, dude, I want leather AC. I want all that good stuff. I don't want to sit in the back, right, in a 10-year-old taxi. So it's like, it's such a great analogy of you got to be mindful.
Mm-hmm. Mm-hmm.
You can't treat your entire fleet like pets and say at some point I'm going to come back to it. No. Set it up for the future. Set it up for automation, right? Mm-hmm. Set it up with the right process loop in there so that you can have it achieve your goals without you spending all of that people capital and energy to go make it happen.
Sound advice. We've been talking a while now. I think people who are listening are probably finishing their morning coffee or at the end of their commute or whatever. So one last question for you, which I think you were just kind of hitting on. Like what advice would you give someone? Like you talked about the code and the optimization and all these things. Could you in a nutshell sum things up from your perspective?
Absolutely. Thank you. So optimization as code is something I would pay attention to, right? It's OAC. The workload optimizations as code. The what is it? And I would pay attention. It should be a conversation at the table when you're talking to your operators, your DevOps, your partners. Number two is future of automation, machine to machine. And it's not Skynet, and it's not even the new Skynet, because I see there's a new Terminator coming out. It's not Skynet, but it's around effective machine to machine communication. And it's preparing for that automation. So prepare your stacks, right? Prepare your software stack. Prepare how you're doing your architecture. There should be some time spent on, okay, how will we use automation to our advantage to either accelerate, lower cost, get out to more markets, what have you. And then the last one's, being an ex-IT data center guy, ex-IT client guy, support guy. There's this part around making sure your operations is in check. So, understanding and enabling your cloud operations. How are you operating today? Are you doing CI/CD? Are you doing DevOps? Are folks ready? Is the architecture ready? But it's like there's this people element of it, of get excited. Be excited about where this is headed and get the folks tooled up and ready to participate at a very different, I'd say more advanced level and a higher efficient level.
Yeah, interesting. It's almost like you should listen to this podcast first and then some of our previous ones where people actually talk exactly about that, the people side, the approvals. And one thing I think is important is that when you talk about putting into the stack, it doesn't mean you don't have approvals. It just means that when you can still have an approval process, it's just when somebody approves it, it happens, as opposed to then having to go and manually edit something and make changes. So you can tool for the automation and still have the kind of industrial strength process around it, but you don't want to be editing Terraform files by hand all the time in the long run. So yeah, I think that's interesting because, knowing what we've talked about in other sessions, it picks right up where you just left off on the people and process side.
Excellent.
That's great, Josh. I guess one last question is, could you give anybody advice on where to rent costumes if one were to want to do I understand you lost your damage deposit on the practice costume.
Dude. Oh, man. I borrowed one. It got ruined. Bought another one. I was asked to send the new one back. I ordered another one because I was asked to wear it to a different activity as kind of a joke. Yeah. Let's just say there's a good amount of costume providers out there. If you find a good alligator one, I will wear it to Orlando next time.
Yeah, you can give everybody your discount code for those because you're such a good customer.
Totally.
All right, with that, let's wrap it up. Thanks so much, Josh. As always, it was really fun talking to you. And everyone, thanks for joining.
Stan, thank you very much.
Oh, thank you so much for listening and joining us today. We really appreciate it. We have so much more content coming, a lot more episodes, so make sure to subscribe to the show so that you do not miss any episodes whatsoever. We'd love to hear from you. Densify.com. You can send us questions, and if you'd like to be on the show, email us, marketing@densify.com. Have a glorious day. We'll talk to you in the next episode.